sine, cosine, and tangent. We know adjacent. We know hypotenuse. This is just a variable. I mentioned it before. That this is, it's called theta. It's a Greek letter. It's just used to stand as a variable for angles sometimes. But it's just a variable. So yes, we know adjacent. We know hypotenuse. So if we want to do adjacent and hypotenuse, we're going to talk to cosine. Cosine's job is adjacent and hypotenuse. Cosine of my angle, which is what I don't know. So we're going to put a theta, equals adjacent goes on top, hypotenuse goes on the bottom. So that means we can rewrite theta equaling inverse cosine of my adjacent over hypotenuse. Which, rounding it to the nearest whole number, I have it here somewhere. There it is. 78.46, so that's going to round down to 78. That should all be reviewing what we did yesterday. Again, this is not anything fancy. All we are doing is we are rewriting so that we can put it in the calculator. That's all that's happening. We're rewriting with inverse sine, inverse cosine, inverse tangent so that we can put it in the calculator and figure out the angle that we don't know. Inverse tangent. Now we're going to add to that. We're going to add to that because we're going to do a process called solving a right triangle. And in solving a right triangle, what you are doing is you are finding all of the measurements of that triangle. So a triangle, it's got 3 sides and it's got 3 angles. We're going to find them all. Boy, that's a whole lot of measurements. Good news, we already know most of them. We already know most of them because it already gave me A to B and told me that's 20. It already gave me B to C and told me it was 15. It already gave me angle B. It's a right angle, so a right angle's got to measure 90. Even more good news, we already solved for angle A. We did it with the inverse tangent and saw that it was 37 degrees. So I'm going to go ahead and put that down too. And now we just got 2 more measurements left to find. Let's start with angle C. All right, I'm going to explain this out the long way, and then I'm going to do this very quickly in every other problem. So to narrow down why this solves the way it does. In a triangle, we have talked about this for the last couple of chapters. The angles in a triangle add to 180 degrees. That's not just a right triangle thing, that's any triangle thing. All the angles had to 180 degrees. Well, we are looking at right triangles. And in right triangles, by definition, I already know one of the angles. Right there. I know one of the angles is 90 degrees. That has to be true in a right triangle. And because that angle is 90 degrees, if I want the 3 angles to add to 180, and I got one of the angles being 90, Well, doing some subtraction tells me that leaves 90 for the rest of them. So I had 90 down, now I have 90 to go. So that tells us that the other two angles when I add them together should total 90 degrees. So if I know that angle A is 37, what's left over is my last angle for angle C is I should be able to just take 90 and subtract off the other angle I already found, which is 37. Now, if you want to combine these two angles together and then subtract them from 180, you're going to get the same thing. The shortcut that I'm using is the fact that I know in all of these, one of them is going to be 90. That's going to leave 90 for the other two put together. So once I know one of the angles, I can just subtract it from 90 to find the other. So that's what I'm going to do in the rest of the problems. Once I know one of the angles, I'm going to take it, subtract it from 90, and that's going to find the other angle. One more to go. We need to find A to C. To find A to C, it's been a couple weeks since we've done this part. Yes. Let me finish this problem. I have two sides that I know. I have this side, A to C, that I don't know and I'm trying to find. And if I have two sides that I know and one side that I don't, it's Pythagorean theorem to the rescue. C is my hypotenuse. Which one's my hypotenuse? Well, it's the one I don't know yet. It's x. So we have x squared equaling a squared plus b squared. So 15 squared plus 20 squared. We'll do some solving here. 15 squared is 225. 20 squared is 400. 225 and 400, that's going to be 625. Rounding. Let me talk about rounding. Any angle measure that we've been getting, we're rounding to the nearest degree, to the nearest whole number. Right? That's what you do on your did on your inverse trig homework. That's what we did on all the problems, pretty much all the problems yesterday. Angle measures round to the nearest whole number. Last week when we did sides, we rounded them to the nearest tenth. So on all the problems that we do over these next couple weeks, angle measures are going to go to the nearest degree, the nearest whole number. Side lengths are going to go to the nearest tenth. And now that I've said that, let me throw that out the window, because square root of 625 is 25, so I don't need to do any rounding at all. Side lengths to the nearest tenth, angles to the nearest degree, and now we have solved our right triangle. we have solved for all our sides and all our angles. All right. Solving a right triangle means give me all the sides and all the angles. You can solve a right triangle if you know the right angle, of course, because it's a right triangle, plus either two side lengths, which is like the one we just did. I knew that one of the sides was 15, the other side was 20, and then I was able to find all the rest of them. Or, which is the one we're about to do, one side length and one acute angle measure. In other words, one of the sides and one of the other angles aside from the right angle. Those are the two different pieces of information that we can be given that will let us solve a right triangle. If I know two of the sides, or if I know one of the sides and one of the other angles. So let's look at an example of figuring out one of the other sides and one of the other angles. Angle M is our right angle. What's the other angle we know? It's going to be angle D. It's 50 degrees. And then we know V to M is 21. Okay, those are the three pieces of information that we know. And now we're going to solve for all the rest. Here we go. First off, I'm going to start with the easy one. I know two of the angles. So like I said on the last one, as soon as I got an angle, then we can get the other one by taking that angle and subtracting it from 90. So measure of angle V is going to be 90 minus 50, which is 40. All right, one down, two to go. Now we have some sides to solve for. I'm going to call this one X, and I'm going to call this one Y, so that we're clear on which one we're setting up and solving for here. Let's solve for X first. This time, unlike my last problems that we've been doing, this time I know my angle. I also know across from the 50, I know opposite. What am I trying to solve for? I'm trying to solve for the hypotenuse. So I know opposite, I want hypotenuse. So opposite and hypotenuse, that's sine's job. Sine of my angle, this time I know it, it's 50, equals opposite, my opposite is 21, over hypotenuse, I don't know it. These are the kind of problems we practiced all last week. Right, using our trig. So we practiced all last week solving this by multiplying by what's on the bottom to get rid of the fraction. So we're getting rid of our fraction, we're multiplying by what's on the bottom. That way, these cancel and I have 21, no more fraction. That was our goal. We wanted to get rid of the fraction. Fraction's gone now. Over here we have x times the sine of 50. Sine of 50 is just a number, so to get rid of multiplying by the sine of 50, get rid of multiplying by that number, I'm going to divide. So we are dividing because it's x times a number. So to get rid of that multiplication, we're dividing. So 21 over sine of 50. That in the calculator should be 27.4. I spent the whole last week giving calculator help, so I'm not going to display the calculator on the board and type it all out every time. If you need help with the calculator, let me know. 27.4. Remember, side lengths, we went to the nearest tenth. So that's why we're 27.4. That was our hypotenuse. So that was V to D, was what we just found, was 27.4. To find M to D, we're going to do something really similar to that. We're going to do basically the same thing, but this time we're solving for y. I don't care about x anymore. I already solved for it. Now I want to solve for y. I have the same angle measure. I still know opposite. I want to solve for adjacent. I know opposite. I want adjacent. So opposite and adjacent, that's tangent's job. Tangent of my angle equals my opposite over adjacent. So opposite is 21, adjacent is y. Opposite, remember, with tangent, opposite always goes on top, adjacent always goes on the bottom. Then we solve. Multiply to get rid of the fraction. Y's cancel here. We have 21. That was what we wanted. Y times the tangent of 50. Tangent of 50 is still just a number, so we still have y times a number, so we're going to divide to get rid of the multiplying. So 21 over tangent of 50. And if you put that in the calculator and round it, you should get 17.6. And we have done it. We have solved our triangle. We have figured out all our sides. We have figured out all of our angles. Tools for solving right triangles, and we're going to drill these tomorrow. Tools for solving right triangles. And we looked at and used all of these today. If we know two sides and we want a third side, that's Pythagorean theorem to the rescue. Pythagorean theorem lets us solve for a third side given the two sides that we already know. When I know two angles and want the third angle, the tool that I use for that is I take 90 minus whatever that measurement was. And we talked about why that is earlier today. If I'm trying to go from angles to sides, if I have an angle that I know and I want to get a side that I don't, that is our trig. That is sine, cosine, and tangent. To get from an angle that I know to a side that I don't. If I want to go the other way and get from a side that I know to an angle that I don't, that is inverse trig. That is inverse sine, inverse cosine, inverse tangent. So again, to go from angles that I know to sides that I don't, you're going to use your sine, cosine, tangent. Sides that I know to angles that I don't, we're going to